Welcome. Today we're diving into the fascinating world of analytical chemistry. This branch of chemistry is all about identifying and quantifying matter, basically, figuring out what things are made of and how much of each component is present. Analytical chemistry is everywhere, from the food we eat to the medicines we take and even in the air we breathe. It's the science behind the scenes, ensuring quality, safety, and innovation in countless industries. In this video, we'll explore why analytical chemistry is so important, how it impacts our daily lives, and the many ways it shapes the modern world. Let's get started by understanding its core principles. Analytical chemistry is a branch of chemistry focused on the separation, identification, and quantification of chemical components in natural and artificial materials. It's the detective work of science, using a variety of techniques to answer questions like, what is this substance? How much of it is present? These answers are crucial for research, industry, and public safety. Analytical chemists use tools ranging from simple test tubes to advanced instruments like spectrometers and chromatographs. By mastering these tools, they help solve real-world problems and drive scientific progress. Analytical chemistry has a rich history, dating back centuries. Early chemists developed basic methods to test for purity and identify substances, laying the groundwork for modern science. Over time, the field evolved with the invention of new tools and techniques, such as titration and spectroscopy. These advancements have made it possible to detect even trace amounts of substances, revolutionizing industries like medicine, environmental science, and food safety. Understanding this history helps us appreciate the sophistication and reliability of today's analytical methods. Analytical chemistry relies on a range of core techniques to analyze substances. These include qualitative methods, which identify what's present, and quantitative methods, which measure how much is there. Common techniques include chromatography, which separates mixtures, spectroscopy, which analyzes light absorption, and electrochemical analysis, which measures electrical properties. Each technique has its strengths and is chosen based on the specific question being asked. Mastery of these methods allows chemists to tackle complex analytical challenges. Analytical chemistry plays a vital role in medicine. It's used to develop and test pharmaceuticals, ensuring drugs are safe and effective. Analytical techniques help determine the purity of compounds, identify contaminants, and monitor the stability of medications over time. In clinical settings, analytical chemistry is essential for diagnosing diseases, monitoring patient health, and guiding treatment decisions. Without it, modern healthcare would not be possible. Have you ever wondered how food manufacturers ensure the safety and quality of what we eat? Analytical chemistry is the answer. It's used to detect harmful substances, verify nutritional content, and ensure products meet regulatory standards. From testing for pesticides in produce to checking for allergens in packaged foods, analytical chemists help protect public health and maintain consumer trust. Their work ensures that what reaches our tables is both safe and nutritious. Analytical chemistry is crucial for protecting the environment. Scientists use analytical methods to monitor air, water, and soil quality, detecting pollutants and tracking their sources. This information guides policy decisions, helps enforce environmental regulations, and supports efforts to clean up contaminated sites. By providing accurate data, analytical chemists play a key role in safeguarding our planet for future generations. Industries rely on analytical chemistry to maintain quality and efficiency. From manufacturing electronics to producing clean energy, analytical techniques ensure that raw materials and finished products meet strict specifications. This reduces waste, improves safety, and boosts productivity. Analytical chemists also help troubleshoot problems, optimize processes, and develop new materials, driving innovation across sectors. Analytical chemistry is a cornerstone of forensic science. It's used to analyze evidence from crime scenes, such as blood, fibers, and unknown substances. Techniques like chromatography and mass spectrometry help identify drugs, toxins, and other chemicals, providing crucial information for investigations. Analytical chemists work closely with law enforcement to ensure that evidence is reliable and admissible in court. Developing new medicines is a complex process, and analytical chemistry is at its heart. Chemists use analytical techniques to characterize new compounds, assess their purity, and monitor their stability. These steps are essential for meeting regulatory requirements and ensuring that new drugs are safe for patients. Analytical chemistry also helps optimize manufacturing processes, making medicines more affordable and accessible. Quality control is essential in manufacturing, and analytical chemistry provides the tools to make it happen. By analyzing raw materials, intermediates, and finished products, chemists ensure that everything meets strict standards. This prevents defects, reduces recalls, and protects consumers. Analytical chemistry is especially important in industries like food, pharmaceuticals, and electronics, where even small deviations can have serious consequences. Clean water is essential for life, and analytical chemistry helps ensure its safety. Scientists use analytical methods to test for contaminants like heavy metals, bacteria, and pesticides. These tests guide water treatment processes and help protect public health. Analytical chemistry also supports environmental monitoring, helping track pollution and assess the effectiveness of cleanup efforts. Analytical chemistry is vital for monitoring air quality. Scientists use sensitive instruments to detect pollutants like carbon monoxide, ozone, and particulate matter. This data informs public health decisions, supports regulatory compliance, and helps identify sources of pollution. Analytical chemists play a key role in developing cleaner technologies and promoting a healthier environment. Healthy soil is the foundation of agriculture, and analytical chemistry helps maintain it. By analyzing soil samples, chemists can detect nutrients, contaminants, and other important properties. This information guides farmers in choosing the right fertilizers and managing land sustainably. Analytical chemistry also supports environmental protection by identifying sources of soil pollution and helping restore damaged ecosystems. From cosmetics to cleaning products, analytical chemistry ensures that consumer goods are safe to use. Chemists test for harmful substances, verify ingredient lists, and check for compliance with regulations. This protects consumers from exposure to dangerous chemicals and helps companies maintain trust and credibility. Analytical chemistry is a key part of product development and quality assurance. Analytical chemistry is constantly evolving, thanks to advances in technology. New instruments and techniques allow chemists to detect smaller amounts of substances, analyze more complex samples, and work faster than ever before. Innovations like high-resolution mass spectrometry and automated sample preparation are transforming the field, opening up new possibilities for research and industry. Research in chemistry, biology, and materials science relies heavily on analytical chemistry. Scientists use analytical techniques to characterize new compounds, study biological processes, and develop innovative materials. Accurate analysis is essential for publishing reliable results and advancing scientific knowledge. Analytical chemistry provides the foundation for discovery and innovation across disciplines. Analytical chemistry is a core subject in science education. Students learn about its principles, techniques, and applications, gaining hands-on experience in the laboratory. This training prepares them for careers in research, industry, and healthcare. Analytical chemistry also fosters critical thinking and problem-solving skills, which are valuable in any field. Analytical chemistry isn't just for scientists, it impacts our daily lives in countless ways. From the water we drink to the air we breathe and the products we use, analytical chemistry ensures safety and quality. It's behind the scenes in everything from food testing to environmental monitoring, making our world safer and healthier. Next time you enjoy a meal or take a medicine, remember the analytical chemists working to protect you. Innovation in science and technology often starts with analytical chemistry. By providing accurate data and insights, analytical chemists help invent new materials, develop better products, and solve complex problems. Their work drives progress in fields like nanotechnology, renewable energy, and biotechnology. Analytical chemistry is truly at the forefront of scientific advancement. Farmers and agricultural scientists depend on analytical chemistry to optimize crop yields and ensure food safety. By analyzing soil, water, and plant samples, chemists help identify nutrient deficiencies, detect contaminants, and monitor pesticide residues. This information supports sustainable farming practices and helps feed a growing population. Energy sector relies on analytical chemistry to develop cleaner fuels, monitor emissions, and improve efficiency. Chemists analyze raw materials, test fuel quality, and track pollutants released during energy production. Analytical chemistry also supports the development of renewable energy sources, such as biofuels and solar cells, by providing critical data for research and development. Materials scientists use analytical chemistry to study the properties of metals, polymers, ceramics, and composites. By analyzing the composition and structure of materials, chemists help develop stronger, lighter, and more durable products. Analytical chemistry is essential for quality control, failure analysis, and the creation of innovative new materials. Biotechnology is another field where analytical chemistry is indispensable. Chemists analyze biological samples, monitor fermentation processes, and ensure the purity of biopharmaceutical products. Analytical chemistry supports the development of new therapies, vaccines, and diagnostic tools, making it a key player in advancing healthcare and life sciences. Cosmetics industry uses analytical chemistry to develop safe and effective products. Chemists test for allergens, verify ingredient claims, and ensure compliance with safety regulations. Analytical chemistry also helps companies innovate, creating new formulations and improving product performance. This ensures that consumers can trust the products they use every day. Art conservators use analytical chemistry to study and preserve priceless works of art. By analyzing pigments, binders, and varnishes, chemists can identify materials, detect forgeries, and guide restoration efforts. Analytical techniques also help monitor the effects of aging and environmental exposure, ensuring that cultural treasures are preserved for future generations. Space missions rely on analytical chemistry to study extraterrestrial materials and monitor spacecraft environments. Instruments on board spacecraft analyze soil, rocks, and atmospheres on other planets, searching for signs of life and understanding planetary processes. Analytical chemistry also ensures the safety of astronauts by monitoring air and water quality during missions. Analytical chemistry plays a role in sports by testing for performance-enhancing drugs and monitoring athlete health. Chemists analyze blood and urine samples to detect banned substances, ensuring fair competition. Analytical techniques also help optimize nutrition and hydration strategies, supporting peak athletic performance. Law enforcement agencies use analytical chemistry to analyze evidence, identify drugs, and investigate crimes. Chemists work in crime labs, using advanced techniques to provide reliable results that stand up in court. Analytical chemistry helps solve cases, bring criminals to justice, and protect public safety. Toxicologists use analytical chemistry to detect and quantify toxins in biological samples. This information is critical for diagnosing poisonings, investigating environmental exposures, and developing safety guidelines. Analytical chemistry helps protect public health by identifying dangerous substances and guiding responses to chemical emergencies. Clinical laboratories use analytical chemistry to diagnose diseases and monitor patient health. Chemists analyze blood, urine, and tissue samples to detect biomarkers, measure drug levels, and assess organ function. Analytical chemistry provides the data doctors need to make informed decisions and deliver effective care. Pharmaceutical companies depend on analytical chemistry to develop, test, and manufacture medicines. Chemists ensure that drugs are pure, potent, and free from contaminants. Analytical chemistry also supports regulatory compliance, helping companies meet strict safety and quality standards. Environmental scientists use analytical chemistry to study ecosystems, monitor pollution, and assess the impact of human activities. Chemists analyze samples from air, water, and soil, providing data that guides conservation efforts and informs policy decisions. Analytical chemistry is essential for understanding and protecting our natural world. Quality assurance teams use analytical chemistry to verify that products meet specifications and regulatory requirements. Chemists test samples at every stage of production, from raw materials to finished goods. Analytical chemistry helps prevent defects, reduce recalls, and ensure customer satisfaction. Regulatory agencies rely on analytical chemistry to enforce safety and quality standards. Chemists test products for compliance with laws and regulations, protecting consumers and the environment. Analytical chemistry provides the data needed to support inspections, certifications, and enforcement actions. Public health officials use analytical chemistry to monitor disease outbreaks, track environmental hazards, and ensure the safety of food and water supplies. Chemists provide the data needed to make informed decisions and respond to emergencies. Analytical chemistry is a vital tool for protecting communities and promoting health. Veterinarians use analytical chemistry to diagnose and treat animal diseases. Chemists analyze blood, urine, and tissue samples from animals, helping identify infections, monitor drug levels, and ensure food safety. Analytical chemistry supports animal health and contributes to the safety of the food supply. Nanotechnology depends on analytical chemistry to characterize nanoparticles and develop new materials. Chemists use advanced techniques to measure particle size, composition, and surface properties. Analytical chemistry enables breakthroughs in electronics, medicine, and materials science by providing precise data at the nanoscale. Geologists use analytical chemistry to study rocks, minerals, and soils. By analyzing samples, chemists help identify valuable resources, understand geological processes, and assess environmental impacts. Analytical chemistry supports exploration, mining, and environmental protection in the geosciences. Oceanographers use analytical chemistry to study seawater, marine life, and ocean processes. Chemists analyze samples to monitor pollution, track nutrient cycles, and understand the impacts of climate change. Analytical chemistry provides the data needed to protect marine ecosystems and manage ocean resources. Archaeologists use analytical chemistry to study ancient artifacts and uncover the secrets of past civilizations. Chemists analyze pottery, metals, and organic remains to determine their composition, age, and origin. Analytical chemistry helps reconstruct history and preserve cultural heritage. Educational institutions use analytical chemistry to teach students about scientific principles and laboratory techniques. Students gain hands-on experience with real-world applications, preparing them for careers in science and industry. Analytical chemistry education fosters curiosity, critical thinking, and a deeper understanding of the world. Manufacturers use analytical chemistry to ensure product quality, optimize processes, and reduce costs. Chemists analyze samples at every stage of production, from raw materials to finished goods. Analytical chemistry supports innovation, efficiency, and competitiveness in the manufacturing sector. The transportation industry relies on analytical chemistry to develop fuels, monitor emissions, and ensure vehicle safety. Chemists test fuel quality, analyze engine performance, and detect pollutants. Analytical chemistry supports cleaner, safer, and more efficient transportation systems. As we've seen, analytical chemistry is a powerful tool that touches every aspect of our lives. From ensuring the safety of our food and water to driving innovation in science and industry, analytical chemistry is essential for progress and well-being. Its techniques and applications continue to evolve, opening up new possibilities for discovery and problem-solving. By understanding and appreciating the importance of analytical chemistry, we can better appreciate the science that shapes our world and supports our future.